So it's already a function of y by x, and therefore it is homogeneous. Of course, I notice that I have an x by y here. That's fine. X by y is 1 over y by x. So instead of like v appearing in place of y by x, I would have a 1 by v here. So that's fine. So I still call it as f of y by x, and therefore this is homogeneous. So we say, as usual, let y by x be equal to v. Cross multiply, find dy by dx. So this is what I get. Y becomes dy by dx. V into x is product rule. So v into 1 plus x into dv by dx. And I substitute all this back into this. So dy by dx would become this. And this is v cos v. This would be 1 by v sine v plus cos v. So that's what I would get there. And the next step would be simplifying this 1 by v. So I don't want a fraction over there. So I want to get rid of that v. So what I'm thinking is, like if I multiply every single term, like in the numerator I have just one term, so multiply that by a v, makes it v square. Multiply this by a v, so this by v gets cancelled and giving me just sine v, and this will be v cos v. So I multiply both numerator and denominator by v. So that's what I would get, because v into v cos v makes it v square cos v. Here the v gets cancelled and this becomes v cos v. So this is what we ended up with. And I shift this plus v to the other side, becomes minus v. Took LCM, cross multiplying. So this is what I get. I open the bracket with minus sign, and then I get this. Then I notice that v square cos v and minus v square cos v would get cancelled. So in the numerator I would have only minus v sine v. And the next step would be to cross multiply both the ways. So this sine v plus v cos v goes to the left side, giving me this, and by dx from the left hand side goes to the right side and appears on the right hand side. But the variables are not completely separated, so this v sine v would come to the left side and this x would go to the right side. So when you do that, the variables are completely separated. Now I have the entire v expression with dv, and this single x from the left side is shifted to the right side, making it minus 1 by x dx. Since the variables are separated, now we can integrate both sides. So integrating both sides, integral of the left hand side is equal to integral of the right hand side, but of course I divided them separately. When I divide separately, I get sine v divided by v sine v gives me 1 by v. V cos v divided by v sine v. V and v cancels. I left it as cos v by sine v because I noticed something, that the numerator is the derivative of the denominator. So that's going to be log of the denominator, natural log of the denominator. So ln of mod sine v. And on the right side it's fine, it's integrable. So when you integrate it, 1 by v became log mod v, natural log mod v, ln mod v. This is ln mod sine v. This is ln mod x plus, usually we call this as c, but this time I have written it as ln c, or sometimes people keep it as ln c1 so that finally they could end up the answer with c. Anyway, I took it as ln c, log c. That's because I'm planning on combining these terms and simplifying. So this is the stage where we have reached now. I look at the left hand side, that looks like log a plus log b becomes log of a into b, and on the right side it is like log a minus log b, which is log of a by b. I removed the two log from both sides, so what I have is modulus of v sine v is equal to c by mod x. I take away this modulus sign now. With the modulus sign, if this is the answer, without the modulus sign it could be plus or minus. So the answer turns out to be plus or minus when I remove the modulus. And I also replaced v by y by x. So two things done in this step. I removed the modulus, so I got a plus or minus. I changed v into y by x. So y by x into sine of y by x is equal to plus or minus c by x. This divided by x cancels from both sides, and plus or minus c is taken as some other new constant, which is the solution. Looking at another initial value problem, x square minus y square into dx plus 2xy, this particular question. Pretty simple. So you could pause the video and watch what's going on here. Pause the video for a little while and see how we have done it. You should try to figure this out now. So left the dy term on the left side and shifted to the other side. Made dy by dx as the subject, and this is what we get. And then we divide each term by x square. So it looks like that. Y square by x square is y by x, the whole square. X square by x square is 1. Here 1x cancels, so 2 times y by x, which is f of y by x. We make substitution, we differentiate and make the substitution with the question. This is what I get, and the next step would be to shift v to the other side, taking LCM. So I have all the working done here. You could pause it, try to do it yourself, and then come back and watch what's happening here and compare your answers. So all these steps are quite very clear. So I reached the integration step, and the integral is okay. This is the direct derivative on top. 1 plus v square has the exact derivative 2v on top, and that's how I made it as log of the denominator. Of course, I wrote natural log ln of the denominator, but I don't know whether you noticed it. I haven't kept the modular sign on the left side. That's because this is already a positive term. There is no need of a modular sign. While on the right side, I still have the modular sign kept. Okay, so it's minus ln of mod x plus ln c1. And the next step is, this is like log a minus log b becomes log of a by b. So ln of c1 divided by mod x. I removed log from both sides. The ln is gone from both sides. So this is what I have. The next step is to take away this modular sign. So that's going to give me plus or minus c1. And plus or minus c1 I would call as another constant, which I'm going to call it as c now. So this is what I would be getting. And I cross multiply the x square to the other side, which will give me just x there on the other side because 1x cancels. And then the initial value conditions, when x is equal to 1, y is equal to 1. And when I substitute those values, I get the value of c as 2, put it back, and that's my final solution. So I have got one more equation, one more example here, differential equation coming up. And there also what I would suggest is that when you see the question, you pause the video